Hey students, Mr. Halpern here. This is a video about the relationship between pressure and volume. Another way that we can describe it is Boyle's law, which we'll get into below. It's a mathematical formula for figuring out if you change the pressure or you change the volume, how the resulting pressure or volume will be affected. So we want to know the basic trends. So if you change the pressure, how will it affect the volume and vice versa? And so the first thing is that we talked about the kinetic molecular theory and the four postulates of the kinetic molecular theory. Now, if you remember in the lab that we did in class where we had all those little demonstrations about chemical and physical properties of gases, you'll remember that the syringe that we had when we filled it up with air was able to be compressed. And this follows the first postulate of the kinetic molecular theory, which states that gas is mostly made up of empty space. And even the gas themselves, the gas particles, are so tiny that we could negate the size of them and say that it's pretty much empty space, which is a fascinating idea in and of itself, right? That gas and the air around us is mostly just empty, a vacuum. But as a result of this property of gases, we can compress that gas down into a smaller volume. So what happens when we do that? When we press down on the syringe, as you see in the picture on the right here, let me pull it over for a sec. You notice that when you press down, the gas gets smaller, right? And as a result of the area that the gas is in getting smaller, those gas particles are going to collide with each other and with the walls of the syringe much more often, more frequently. And as a result of the fact that there are more collisions, there's going to be a greater total force against the sides of the syringe and against each other. And so as a result of that, that would increase the pressure. Because remember, pressure is literally an object applying a force over a given area. So remembering the formula, pressure equals force over area, that would give you a general idea of why the pressure would increase if you decrease the amount of space for the air to go. Okay, so the relationship that we want to remember is as pressure increases, volume decreases. One more time, as pressure increases, volume decreases. And we can do the alternative, right? As pressure decreases, volume increases. So as a result, they're inversely proportional to each other. They're inversely proportional to each other. Well, what does that mean? It means that as one goes up, the other one goes down, essentially. So now that we kind of understand that, let's apply it to a problem. This problem is going to be associated with the graph to the right. So you know that, let's say that you know that initially a gas sample occupies a volume of 8 milliliters, which is a pretty small area. That's about the size of the syringe that you had. And it exerts a pressure of 1 atmospheres. So inside of the syringe, let's say, the pressure that is felt right on the sides of the syringe is 1 atmosphere. And the question is, how would the pressure of the gas sample change if its volume was increased to 10 milliliters? So think about it for a sec. If you take that syringe, right, that's 8 milliliters of space, and you allow that gas to now move around in 10 milliliters of space, right? What's going to happen? Well, first of all, there's going to be less collisions, right? Therefore, there's going to be less force against each of the particles themselves and against the sides of the syringe. And so therefore, the pressure is going to go down. So a little statement here. It says the pressure should be less than 1 atmosphere because pressure and volume are inversely proportional to each other. More volume equals less pressure. That's what we did. We increased the volume of the syringe, decreasing the pressure. And then if we were to draw a sample of what this would look like, right? As we were increasing our volume, what was happening to our pressure? Well, as we increased the size of the syringe area or volume inside, okay, there were less collisions and therefore less pressure. So our graph, I'm going to draw this on your paper, graph is going to look like this, starting up from the top left, going down to the bottom right. We have a mathematical law that was created by a man named Robert Boyle. He was an English scientist who studied gases and really was the first person to propose a quantitative law, meaning a law that we can plug numbers into and figure out this relationship mathematically. So, initial state. So this is the basic formula. P1 V1 equals P2 V2. And when you have P1 and V1 right next to each other, it's implied that they're multiplied. Okay? Same thing with P2 and V2. So, we're going to take our problem from above where we said we had 8 milliliters of volume at 1 atmosphere, and we're going to figure out specifically if we had 10 milliliters of volume what the pressure was. So we're just going to plug in these numbers here and see what we get. So we know that our initial pressure is 1 atmosphere, right? And I'm going to underline that so you know where I am, right there. And we also know that our initial volume is 8 milliliters. Our initial just means, in this case, 1, right? The first, right? That's P1 and V1. P2 and V2 are our second pressure and second volume. So what we did in the problem was we changed the volume. So V2 was now 10 milliliters. And what we wanted to figure out was what P2 was, what the second pressure was. So we're going to plug all of this into the equation. P1 V1 equals P2 V2. And what do we get? We plug in P1, which is 1 atmosphere. We multiply it by V1, which is 8 milliliters. And we don't know what P2 is, so we're going to leave that as a variable, right? Just like in math, we leave, variables like x or y in our equations. And then we put multiply, and then the V2, which was 10 milliliters. And we're going to solve for P2, the one that we don't understand. We don't know. So what we do is we're going to take that 10 milliliters, we're going to divide it on both sides, and we're going to get P2. And we get 0.8 atmospheres. 0.8 atmospheres shows us that we were correct in our assumption that the pressure would decrease if the volume was to increase. Okay? Because what happened? We started at 1 atmosphere, and now we're at 0.8 atmospheres. Right? A little bit less because of our increased volume. So that's how that works. Now, could I give you a problem that didn't have the volume, the second volume, but had the pressure? Sure, I could. Okay, in that case, you would just plug in the numbers for the variables that you have, and still solve for the one that you don't. Okay? I could even give you the final state, right? What the result pressure and volume was, and then I'll give you maybe one of the initial states, like V1, and you'd have to figure out what P1 was. What's the initial pressure? So all of that is just plugging into the equation. But it's important from this video that you understand the relationship between pressure and volume, that you understand what Boyle's law is, that you know what the formula is, and how to solve problems using it. Okay? Take care.